what we have seen so far is what is the relation of the slope with respect to line, and we have exploited certain how we can use the slope to determine whether the lines are parallel, perpendicular, and if I know the slope of the line, then how will I find slope of two lines, non-vertical lines, then how will I find the relation between angles and other properties. Now we will come to the representation of a line. As we have already seen, slope cannot represent a line uniquely. So what is it that is required for representing a line uniquely? So this raises two questions: how to represent a line uniquely, and the second question is, given any point, how will you decide whether that point lies on the line or not? In order to answer these two questions, let us take the first question first and rephrase it. So if I want to represent a line uniquely, then what I need to figure out is, I need to figure out a condition or a definite expression which will describe the line in terms of its coordinate plane. So for a given line L, I should be able to find a definite condition or expression which describes the line in terms of coordinate plane, that is in terms of the coordinates, or to be more precise, what should be the condition on the coordinates in order to describe the line L. If I can understand what is this condition, then the second question is automatically answered, because if the coordinates of P are given to me and they satisfy the condition or expression for the line L, then they must lie on the line L, otherwise they do not lie on the line L. Then it is just a simple job of checking whether that condition is satisfied or not. So with this in mind, we will try to answer the first question, that is how to represent a line uniquely. Now what kind of lines we have seen so far? We have seen lines which are similar to x-axis, lines which are similar to y-axis. Those are typically horizontal and vertical lines. Let us first understand what is a horizontal line. So a line is said to be a horizontal line. A line is said to be a horizontal line if it is of this form. If it has this form. Now this line can be infinitely many, right? So you can have infinitely many horizontal lines, as can be seen from the video. Now how to represent this line uniquely is my question. So let us say I need to find this line or the condition for this line. How can I find the condition for this line? So let us first define this line as a horizontal line, and let us say a line is a horizontal line if and only if it is parallel to x-axis. This is our definition of a horizontal line. Now if I want to specify this line uniquely, what do I need to know? I need to know the distance of this line or the location of this line from x-axis. That is, I need to know the y coordinate of this line. You can see here. So I want to locate this line or the value that it takes on y-axis. If I want to specify this line, let us say this value is given to be a. If this value is given to be a, then I know it is a horizontal line. So all points will lie at the same distance from x-axis. Therefore all points will be of the will satisfy the condition y is equal to a. Right? You take any point on this line, it will satisfy the condition y is equal to a. So in case of horizontal lines, what I have done is I have identified the condition, that is y is equal to a. So what will be the condition on points? The points will be of the form x comma a. X can be any value, but the y coordinate of that point will be fixed, that is a. In a similar manner, we can consider vertical lines. So what is a vertical line? You can see this in this image, and in this video we can see all these kind lines are called vertical lines. So how will I identify these vertical lines? First, I will define the vertical lines. A line is a vertical line if and only if it is parallel to y axis. Now, to specify the location, what do I need? To locate a line, I need to know the distance of this line from y axis. Okay. So, that essentially means what value it takes on x coordinate or x axis. Okay. So, how will you identify this? You just need to identify the one point in this particular line. Let us say this is the point, and I need to see what is the distance of this point from x axis. That if that is b, then all points of the form b comma y will be lying on this line. All points of the form b comma y will be lying on this line, and therefore the equation of the line, the expression for the line, will have a form x is equal to b. As mentioned, the all points will be of the form b comma y. So if I get 2 points where the y coordinate, where the x coordinate is fixed, then I know it is a line, then I know it is parallel to y axis, or it is a vertical line. Right. In a similar manner, the other one is parallel to x axis, and it will be a horizontal line. Let us make it more crystal clear by solving one example. So here is an example where a question is given to you. You want to find the equation or expression for the lines parallel to the axis and passing through point 5 comma 7. Now the lines are passing through point 5 comma 7, right, and it is also given that they are parallel to axis. So a line which is parallel to x axis is known as horizontal line, a line which is parallel to y axis is known as vertical line. So essentially this question asks you to find one horizontal line and one vertical line. So let us go to the coordinate plane. This is the coordinate plane. Let us locate the point 5 comma 7. It will be somewhere here. The point will be somewhere here, 5 comma 7. Now if let us first focus on identifying the horizontal line. So as what is a horizontal line? A line which is parallel to x axis is a horizontal line. So a line which is parallel to x axis, then what do I need to know? Its distance from x axis. The distance is 7 according to this particular expression, because 5 comma 7 is a point on that line. So the distance is 7. So the line must appear somewhere here. It is appearing here. Correct. So this is the distance 7, and now further the next question is, I want to find a vertical line that passes through point 5 comma 7. So now I need to know the distance of a line from x axis. So I will locate point 5 over here, and all points on the line, on the that particular line, will be of the form 5 comma y. So 5 comma 7 will also fall on that line. So this is the line. So this is how we will find the lines. Now what are the typical equations of the line? So for this line it will be y is equal to 7, the horizontal line will be y is equal to 7, and the vertical line will be x is equal to 5. This is how we will study horizontal and vertical line. So what is a vertical line? Vertical line has inclination as at 90 degrees. Its intercept is 90 degrees, and therefore the slope of this line is not defined. Remember this in mind. And another point, which is horizontal line, it never intersects actually x axis, but the inclination of this line with respect to x axis is 0 degrees. Therefore it will have a slope 0. So we have eliminated the cases where the slope do not exist or slope is 0. Now we need to identify similar kind of expressions for lines which are not vertical. So let us go further and identify such expressions. So here, as we already know that slope cannot uniquely determine line. Then the question is, which slope, if I give you some more information, can you determine the line? So here in this case what we are identifying is, we are giving a point and giving a slope, and then we are asking a question, can we solve this problem, or can we find a unique expression for a given line? So the question is, for a non-vertical line L, vertical line we don't have to consider because it doesn't define, the slope is not defined. So for a non-vertical line L with slope m and a fixed point p x naught y naught on the line, can we find the equation or the algebraic representation of a geometric object that is line, is the question. So here what are the things that we know? We know slope and we know a point on the line. So in order to answer this question, we know that 2 points uniquely determine a line. So let us take another point q x comma y. I don't know the coordinates of these points, but I assume that this point lies on line L. Now I know from the definition of slope that I have defined, change in y by change in x, the slope of a line is given by, so what are the 2 points now? Q and P. So change in y will be y minus y naught and change in x will be x minus x naught. Okay. So I know m is equal to y minus y naught upon x minus x naught. This is what I know from my definition. It has nothing to do with tan of theta. Even if you have it, you can find out what is tan of theta, but since nothing is known in specific, we cannot find the tan of theta. But tan of theta is anyway given to you in terms of slope. Okay. So now I have m is equal to y minus y naught upon x minus x naught. So how will I find the condition on x and y? Just cross multiply this x minus x naught or multiply throughout by x minus x naught, you will get an expression which is y minus y naught equal to m into x minus x naught. This condition uniquely identifies my line. There cannot be any other line passing satisfying this condition. So therefore, any point that lies on this particular line, that is p x comma y, that lies on this particular line, it must satisfy the condition that is given here. Okay. This form of expression is called point slope form. So this is a point slope form of equation which essentially says that give me one point and slope of a line, I will give you the equation of a line. The beauty is the geometric object now can be represented in terms of the equation. Initially what we started, when we started, we tried to represent a point which is a geometric object in terms of coordinate plane and the coordinates of the point. Now we are giving infinite set of points having certain condition, that is a geometric object of line, how you can represent it algebraically using the equation of a line. So this is point slope form. Let us try to see how we can use the point slope form in our solving problems. So now I have been asked to find the equation of a line which passes through point 5 comma 6 and has slope of minus 2. Here the interesting thing is slope is negative. So let us identify the point 5 comma 6 on the coordinate plane, and now I want to identify the point, the line that passes through this with slope of minus 2. So now I have a formula for point slope form. I can use that formula and I can straight away derive it. For let us try q x comma y is an arbitrary point, so I need two points to identify a line. So q x comma y with the arbitrary point on this line. Then using point slope formula, we simply substitute minus 2 is equal to, so change in y will be y minus 6 upon x minus 5. So simply substitute that minus 2 is equal to y minus 6 upon x minus 5. Slightly rearrange the terms. What you will get is y minus 6 is equal to 2 times 5 minus x. If you simplify this, you will get the expression y is equal to 16 minus 2x. Now let us try to see whether if I want to know for this value of x, what value of y will satisfy this equation. Let us put x is equal to 3 here. If I put x is equal to 3 here, then I get y is equal to 10. After simplifying this, I will get y is equal to 10. So that means the point 3 comma 10 should lie on this particular line. So let us see that 3 comma 10 is here. And now you know from basic geometry that 2 points uniquely identify a line. So you can just draw a line on using your ruler passing through these 2 points. This is the line that we are expecting. So the question didn't ask you to draw a graph, but drawing graph always verifies whether you have found a correct answer or not. So it is better to cross check using graphs. So the equation of the answer to the question is the equation of the line passing through point 56 and slope minus 2 is y is equal to 16 minus 2x. Now suppose somebody decides not to give me slope and somebody says that now you have been given only 2 points. Can you find the equation of line? The answer is obviously yes, because given 2 points I can always determine the slope. Right? For example, in our earlier case when we defined slope, I need to figure out what is change in y and what is change in x using these 2 points, and that will give me slope to be equal to minus 2, and therefore I can always use this formulation to find the equation of the line. But you can use this knowledge and derive another form, that is equation of a line 2-point form. So given 2 points, the question is, can you determine the line uniquely, which should be possible, and through our basic knowledge of geometry we already know that 2 points uniquely determine a line. Now we will see that in our coordinate geometry. So the assumption is, let the line L pass through points P and Q with coordinates x1 y1 and x2 y2. To start with this, I will take another point R, which is arbitrary point, because I want to find the condition in terms of coordinates. So I will always, whenever I want to find the equation of line, I will start with an arbitrary point. So R x comma y is an arbitrary point on the line L. Now look at these 3 points P, Q and R, they all lie on one line. Therefore the points P, Q, R are collinear. Yes, so points P, Q, R are collinear. Therefore, suppose I consider only these 2 points P and R, I can easily figure, using these 2 points P and R, I can easily figure out the slope of a line. If I consider points P and Q, I also know the slope of a line. Now because these points are collinear, what can you say about slope of line PR and slope of line PQ? Both must be same or equal. So slope of PR is equal to slope of PQ because they are collinear. So if this is the case, then what is slope of PR? You can easily figure out. P is this x1 y1 and R is xy. So the slope of PR, first you consider change in y minus y1 upon change in x, that is x minus x1, that is slope of PR. What is slope of PQ? PQ is x1 y1 and x2 y2. So change in y is y2 minus y1 and change in x is x2 minus x1. Therefore I will get the equation of this form, y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So again, if you look at it closely, this particular thing is nothing but the slope of a line M, and we are doing things which are very similar to slope point form. So now instead of counting it explicitly, we are counting it as a ratio. And then you rearrange the term and you will get this expression, because you just take this denominator on the other side and you will get this expression. Now any point that lies on this line is again uniquely characterized, and therefore any point that lies on this line must satisfy this condition, right. So, if your point is R lies on this line, then it must satisfy this condition, and this form is called 2-point form. So, remember these are the formulas that we are deriving. First was slope line formula, second is 2-point form. Let us understand this formula better by solving some examples. So, let us take one example where I want to find the equation of a line that is passing through 2 points 5, 10 and -4, -2. Let us identify these 2 points on a coordinate plane 5, 10, -4, -2. I want to find the equation of this line. So, I will use another point Q, which is an arbitrary point, okay, and it has a coordinates x, y. I will use the 2-point form. So, using 2-point form, what should I get? Change in y, so y minus 10 upon, so I am taken this point P. So, y minus 10 upon x minus 5 is equal to, just see this is change in y, that is -2 minus 10 upon -4 minus 5. See, always remember this order does not matter, I can always start with this as well. So, change in y is 10 minus -2 and change in x is 5 minus -4. In both cases my answer to this particular fraction will be 12 by 9, which is 4 by 3. So, it does not matter whether you take this as x1 y1 or you take this as x1 y1, you will always get the same answer. So, if you simplify this, you will get the expression of a line, because as I mentioned the slope was 4 by 3. So, you just simplify this, you will get the expression of a line 3y is equal to 4x plus 10. So, this will be the line that is passing through these 2 points.